Hello, ladies. I just realized there's no music. Hello, ladies and gentlemen. We're live. We're having a good time. I said I wasn't gonna stream, but that was a lie. It's a partial lie, chat, because yes, I'm streaming, but we're being productive while streaming. So I have my physics notes here. They're really boring, but they're nice and like color coded and stuff, right? So, I've learned I have a bit of a problem, and that is that this sounds like we're in a Catholic church. Because it's got pipe organ in the title. My mic is peaking. I'm so sorry. I'm so loud today. Okay. No, I have a physics exam on Friday, and I have not been taking notes in probably about 2 weeks. So what I'm going to do today is I'm going to sit here with you guys and take my notes, learn some funny number things, and yeah, honestly, just kind of have a good time. The first thing we're covering is Kepler's law. To the physicists who are here, who may happen to be here, y'all know what Kepler's law is. That's space and stuff. I'm not studying astrophysics. I'm just trying to meet my requirements for engineering, and that is goal number 1. But yeah, that's what we're doing. I'm gonna pull up chat here real quick so I can see it. Well, I have it like side by side. So that's what I'm doing right now. My process for doing this isn't the most thought out. However, it works. Yeah, so that's what I'm gonna do. We're gonna study, we're gonna have a good time, we're gonna learn, we're gonna sit here and learn together. I don't know what Kepler's laws really are. Like I have a general idea. And I don't know. Yeah. We're just here to learn. You chat can assist me and hopefully help reinvigorate my slowly dying aspirations in the engineering field. What color best represents Kepler's law? I'm thinking purple, because I feel like space is like a purple kind of vibe, you know? When I think space, I think purple. So, that's what I'm gonna do. Okay, Kepler's law. You're gonna have to just, like, listen to me, right? But we can sit, we can talk, we can have a good time. We'll talk about science, we'll talk about planets. I'll tell you what I do know from physics and what I need to know for physics. Because I have to learn all of this material by Friday and score at least a 70 on the exam. The thing that sucks, too, about the physics class I'm currently in is that it's, by definition, a weeder class, and it's not, like Orgo. If you've taken Orgo, you'll know, Orgo itself is, like, also a weeder class, but it's on a curve. Physics, however, entry-level physics is not graded on a curve. And that sucks. Alright, no more freaking whatchamacallit. Alright. No, we won't let him know that I'm live. Okay. Maybe I'm just not feeling it. I need to get this done. Laws of planetary motion. That's not too loud, is it, chat? It feels like it's loud. Oh, no, it's not even showing up at all. God, that's so stupid. There you go. Now you can hear chat. Hi, Jump. How are you today? Dun, 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 dun. Dun, 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 dun. Still in class. That's okay. We're learning together, Jump. We're learning together. We're learning about different things, but we're learning together. Alright, Kepler's laws of planetary motion. There are, count them, three laws. Who is Kepler? What's his first name? You know, what's his favorite food? Before we can learn about Kepler, we must first learn about Kepler. Sorry, guys. I am literally operating on it's the no thoughts head empty. I can't check Snapchat, Jump. My phone is my camera. Unless I just manifest another iPhone. I can't really do that, though. Yeah, aw fuck indeed. Big Sadie moment. God, Google Meet. Bruh. God is in your Google Meet. Holy frick. What are you gonna do with such a foreboding presence? Dude, I will literally give you $5 right now. You should convince your teacher. If you're in like science or math class. You're in science or math class right now. Be like, yeah, there's this streamer doing physics right now. Don't do that. Don't do that. Don't do that. I don't want a bunch of teenagers. You're in Chinese class. Damn, I don't know Chinese. Bum bum bum. If you were to redeem change games, we'd switch to studying for math. I'll just switch subjects. But I really don't want to do math right now, so I might just deny your request. Not gonna lie. Bum bum. Would you? Yeah, you would get a refund. I know how to do that now. So, does it really matter to redeem it in the first place? If I just have to give you a refund? Yeah. Logically speaking, it doesn't. Is the music too loud? I mean, it would block the redeem for that's true, it would. But I could also just redeem it. I forgot I put a cap on that. You rockin' with perihelion axes? I sure am. This kind of slaps. Closest point in sun-planet orbit. Should you redeem it? I don't think so. No, it's fine. I mean, it really is up to you. But I will say you're just gonna get it refunded. Sun planet orbit. Okay, and then we've got to define our variables because we have A and E. So then A in this equation is... You want refund to be tested? Okay. Holy frick. I'm surprised you had that many freaking channel points. Let me go to my dashboard. There you go. Did you get your points back? Jump. Yeah, I told you. Refund acquired. A is the semi-major and change game is out of stock. Hell yeah. Or, so the semi-major axis acts as the radius for a circle. You know, big props to whoever spends their whole life studying planets, because my pea-sized brain doesn't want to comprehend this. Eccentricity. I think that's how, like, ovular, how not circular it is. Bum, bum, bum. Bum, 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 da, bum, da, bum. Da, 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 da. Dun, 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 dun. Planetary orbits sweep out equal areas in equal times. Alright, time to put my drawing skills to the test. I'm gonna make a diagram. Got slammed with an ad upon arrival. I'm so sorry. Oh no! Should have been sub. You damn right. No, you don't need to sub. Ads get money. Yeah, they do. Not a lot, though. It's like a penny per viewer. I think, I haven't done it yet, but like actually running an ad, I think gets me a little bit more. But I really don't feel like subjecting my audience to having to sit through a minute-long ad. That doesn't sound like fun to me. Bum bum bum. Yo, are we rocking with this cowboy music? Yo. Ba 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 da da da. Kinda can rock with this cowboy music, boys. Yeah. Hell yeah. Ba ba. Yeehaw. Am I right? Cowboy land, like, it's not cowboy land where I'm here. No. Yo, this slaps though. The banjo! The banjo. You're in cowboy land. Yee yee. Yee yee. Do we need a cowboy, Maddie? We'll call it yeehaw. See, Jump, you say you're in cowboy land, but to me, like, cowboy land is, like, Texas. Texas is cowboy land. I'm in Canadian Texas. Oh, my man. The Texas of Canada. The Texas of Canada is Alberta. Is it really? I don't know what all like the Canadian stereotypes about other areas are. Oh, yo, you have a saddle dome. That is very cowboy-y. Cowboy-y? Saddle dome. Sadie. No, that's a saddle. Yes, very cowboy around here. I bet. We don't really have cowboys here. Like, I'm trying to think of, like, what the Midwestern equivalent to cowboys would be. Maybe, like tractor drivers? John Deerers? Those lads. They're, like, the Midwest cowboys. Because, like, literally, it's such a common thing here in the Midwest to like you'll literally be driving on the highway trying to go like 70 miles an hour, and you'll get stuck behind some guy in his hay, and he'll be going 40 and a 70, and it's so obnoxious. The period is related to the semi-major axis. You know what I learned this year? We have a stampede in July filled with random cowboy. Really? That's kind of funny. Y'all have a cowboy day. I do. Free breakfast is always good. I had breakfast today. I had pancakes. Pancakes are so good. That's probably why. I had coffee too. Can you tell? What did I learn? Absolutely nothing. Oh, yeah, no. I learned what the symbol for proportionate, like a proportion symbol. It's this funky Greek letter. It looks like, here. It looks like this. And I didn't realize, like, this was an actual mathematical thing, that we needed, like, symbols for proportions. But it looks kind of like a fish. It looks like this. Did you know that's the symbol for proportion? Because I didn't. So, like, if you want to say, like, not necessarily that something's equal to it, but proportional, you would use that instead of an equal sign. It's not a fish. It's some funky Greek letter or something. It's just, it's its own symbol. I'm not entirely sure where it came from. Alpha. It's alpha. Is it really? It's stuff for, like, inverse. Oh, I didn't know that. I thought alpha looks different, though. Alpha looks more like an A. Okay, wait. Alpha, beta, gamma, the list goes on. It sure does, Frost. It sure does. Dun, dun, dun. Yeah, what is this funky... yeah, that lad! This lad. That's an alpha? Yeah. Not to be... yeah! Okay, I'm on the Wikipedia page for proportionality. Dun, 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 dun. They're the same? Alpha's close, but not the same. Okay, that's weird. Because, like... oh. Excuse me. Alpha's also used in physics, so, like, it makes... I don't know. Physics is weird, because they have, like, 80 symbols. Alpha's squished. Bum, 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 bum. Ba-da-da. Bum, bum, bum. Ba-dum, bum. Yeah, the Wikipedia page says not to be confused with the green letter alpha. We all learned something new today! Yes, we did! Yes, we did. Elongated alpha. Yeah. No, I didn't know that there was a symbol for proportionality. I've always just used an equal sign, because, like, if you're solving a proportion, you use an equal sign, right? Because in Big Man Kepler's law, the period squared is equal to the semi-major axis cubed. See, I do remember that. So the equation for it looks like this. I bet you really can't read my handwriting. It's probably too low res. And it's also cut off. Whoopsie. Alright. Look, you can see. I'm just writing my notes in my crappy little handwriting. Yo, this is some intense ass music. Holy frig. Just gonna Oh, I muted it. We're just gonna skip to the next song. I'm a little too tired for dubstep today. It's noon. Nothing says lunchtime like dubstep. Period squared is proportional to semi-major axis cubed. We can also write it as period directly. It's proportional. I have to change the way I draw my alphas so that I can distinguish between the proportionality sign and alpha, but we're not changing that today. Okay. Ooh, I like the rain. Quite a vibe. Although it's a little trippy, not gonna lie. Not physics getting views again! Listen, it was calculus last time. You know, we're just here. We're all here to partake in the joy that is mathematics. Seems like they're my most popular streams. You know what? Forget gaming. I'll be a math streamer. I'll only stream math. Math and physics. You know? I'm very content with that, not gonna lie. Because it combines, like, just, like, all the weird passions I have. I do want to make a Discord bot, so I would really, really like to stream the coding process for that, because I'd be teaching myself a new coding language. And honestly, like, my favorite thing about when I stream, like, work like this is oftentimes it, like, gets to the right audience, because a lot of people like looking at the engineering tag and whatever else. And so because of that, they're able to help me. And I've had a few people who are, like, actual engineers come tune in and, like, actually help me. And it's so nice. Because I am but a simple plebeian amongst these big boys. You know what I hate? Newton's law. Big man Newton has only created problems for me. He made calculus. He's got something about forces. He's the reason we think about gravity. Which is cool. Gravity's cool. It does a lot. Do I care? I don't know. That's to be debated. I just spilled water all over my notebook. Don't mind me just grabbing a tissue and cleaning up the giant mess I made. Class has been going on for half an hour and we haven't done anything. Welcome to my life. That's how it goes. Maddie moment. Yeah. I'll try to narrate because you guys really can't, like, read what I'm writing, which is probably for the best because I don't want to, like, get in. Yeah. I don't want to get into any legal trouble with my university, but at the same time, like, knowledge is, like, kind of public at this point because, like, everything's on the internet, right? Yo, this grooves too. We are hitting nothing but bangers today. Knowledge is free, you just have to grab it. Precisely. Tempest, are you also in Chinese class right now? Tell that to college! That is absolutely correct. Yep. Then leave it all at the uni when you graduate. You know, honestly, that's kind of how it goes, right? Because, like, I do like what I'm learning in uni, but at the same time, like, how applicable is it? You and Tempest stuck doing nothing. That's okay. Y'all can vibe here. I can't teach you Chinese, but I can talk about Kepler's laws. Ellipse is spelled with 2 L's. Did you know that? I didn't. With E mech being less than 0, if velocity is less than the escape velocity, the path will be a parabola. If velocity is equal to escape velocity, and a hyperabola. Yeah, hyperabola. It's been a minute since I've seen one of those bad boys. If velocity is greater than escape velocity. We won't show this, but Newton did. Good for Newton. Like I said, my life would be so much easier if Isaac Newton didn't have to think. But it's okay, chat. We're gonna do well on this exam. A power play would be to stream the exam, but that is incredibly illegal. I cannot do that. Sorry. If he ate the apple instead. Exactly. Exactly. Big man should have just had a snack. We don't need all this nonsense. Right? Path will be a... I'm gonna make the word parabola purple. Parabola seems like a purple kind of word. What's your favorite, like, linear equation, or, like, not linear equation. What's your favorite type of equation? Because I can really mess with parabolas. I think they're fun. Exponential decay is another fun one. I really like interest graphs. I really like statistics. Would I ever take a statistics class? Only if, like, biology requires it, which I know it does. I really like, and I'm so glad Spotify does this, data analysis, like data visualization. If I could go into data science, I would. I've thought about it. This slaps too. Guys, we're only listening to bangers today. DMCA, safe bangers nonetheless. Oh, what's that? Wait, let me Google it. Let me Google it. Oh, fluids? Oh, fancy. I'm on the Princeton HTML page for it right now. Fluid dynamics. That's kind of gross, but also very fun. I will probably take fluid dynamics, but it won't be till my senior year. I'm but a humble freshman. Mechanical engineer, so that's what I do most of the time. Oh, fun! That's fun. I'm aiming for biomedical engineering right now. So I know I'll for sure have to take a fluid dynamics class because, you know, blood is a liquid. But, am I looking forward to it? I'm not sure. I have a lot of friends that are, chemical engineers. and they talk about it. Lots of thermodynamics and chemical engineering too. Bop. We'll follow the ellipse. Okay. Now for, oh, that's not an L, that's a G. I can't do cursive. No. I just wish I understood physics better. I don't know, maybe if it's just the format it's being taught in this year, or if it's just my inability to retain anything taught to me in an online format. But I am the big struggling right now. Equals 1/2 RV. Does that say tangential? Or we're just gonna write tan. Tangential velocity. That sounds like so much fun. B perpendicular over 2 equals mass velocity perpendicular radius over 2m, which just equals L over 2m. Look for applications like, what is this equation used for, and not pure theoretical. That's valid. It's a little hard to apply it right now because it's all Kepler's law, and it's very, very hard because I am a very visual learner, and so if I can visualize the example in real life with models or something physical I can hold, then it's great. It does wonders for me. However, it's very hard because Kepler's law is planets and stuff, and I can't just formulate a planet. Hello. Yo, did you hear the dog barking this funky music? Oh. You're streaming too? Hell yeah. Dude, kinda gonna skip the doggy music, not gonna lie. Though it's an interesting instrument, I will say. Dude, groovy bassline. You're on both streams. Jump, you are 4 parallel universes ahead of all of us. Since the force on the planet is toward the sun. And you're still in class. Jump, your ears must be overwhelmed with all the noise. Technically 3 streams, oh my god. Wouldn't it be a power play to get everyone in the server live at once, and then we just have this chaos? Toward the sun, gravity doesn't exert a torque on the planet, so torque is equal to 0. L is a constant. Yo, I can freaking rock with this music. I love arpeggios so much. Arpeggios are great. I'm gonna draw this out and see if I can better understand this relationship. Because I understand that the area... Here, I'll show you guys in a minute. Let me finish drawing it. Dude, spooky. Spooky tune. This is a really shitty drawing, and I'm so sorry. Let me tell you, I'm getting a minor in fine arts, too, and that's just the most ironic part of all of this. But that's fine, okay? Physics notes aren't where the good drawings go. Okay, let me show you the drawing, guys. You got this fun thing. So this dashed line represents the orbit. These two are the areas formed by, I think, the semi-major axis. And so then the area in this case is equal to 1/2 the radius times the perpendicular velocity times delta t. So it's the area as a function of time, which I think will change as the orbit proceeds, but I'm not sure. If anyone has suggestions for where to model orbits as they observe Kepler's law, that would be wonderful. This is YouTube tutorial music. You wouldn't know. That's fine, Jump. You're not obligated to know. For a circular orbit. Classic Chinese is review right now, so I might just ignore it. You could do that. You are fluent in the language, so it's up to you. Do you feel it beneficial to review? If not, you have every right to ignore it. At the end of the day, that's your decision. You're responsible for your education. T equals 2 pi r over velocity. So then from F equals ma, we have gravitational constant times big M, little m, over r squared is equal to mv squared over r, solve for v, over r. And then we get that velocity is equal to, making it green, velocity is equal to the square root of gravity times big M over R. So when we plug it back into the initial equation, I am going to skip this song. I'm trying to find like my favorite one off of Colors of Mayhem. That's the album we're listening to. Found it. I found it, boys. It's such a good song. Fun stuff. Oh, you know it. You know it. Always on that math grind. What are you streaming right now, friend? Oh, you're drawing. That's fun. Dude, Gold Pilot is such a good song. I don't know what makes me love it so much. It's probably the split audio channels. I think any song that incorporates split audio channels, like, into it, automatically, like, just such a better song. You can't really see the green that well. But we're just writing equations. We're here to review, we're here to chat, we're here to talk through everything we're learning, because then it'll just reaffirm, and it actually helps me remember. I've learned that this is the best way for me to study. It's a little unconventional, but that's fine. I'm comfy with it. We're having a good time. We're having a good time, chat. Okay, t squared is equal to 4 pi squared over gm r to the third. Where did all those numbers come from? It's easy to show for a circular orbit, but it works for an ellipse too, with r going to a, the semi-major axis. What the heck is Oumuamua? The path of Oumuamua. Recorded in January of 2017. We observed its orbit, and it's one of the first hyperbolic orbits. A log-log plot showing Kepler's third law. Kepler's third law for our solar system. I think it's insane how physics applies to the universe, because it's very, very expansive. All the orbits of the universe follow a linear slope of 1.5 on a logarithmic scale. That's nuts. Okay, now we're getting into energy of orbits. And angular momentum. Pog. I think angular momentum is conserved. Bum 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 ba-dum bum bum ba-da-da-da. Bum ba-dum bum bum ba-da-da-da-da-da-da. Bum. Oh, that's not how you spell Kepler. I spelled it with a T. It's my first instinct when I'm like writing an L, to dash it like a T. Bum bum bum. Mechanical energy determines the size of the orbit. Hell yeah. Bum 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 bum. Just trash my whole sketch. Why'd you do that? And don't put a Bob Ross emote next to that. I saw it. It looked good. Are you clowning? Oh, really? You can hear me. I can see it in Streamlabs. Wait. Are you pranking me? Or do I actually have to click on my stream? You clown. You're so mean. Oh, you can't hear me. Oh my god. Y'all, I'm a fool. Oh my god. Don't call me an idiot. No. I know, okay, I know. This is a typical Monday here at twitch.tv/waffles8me. What do you expect? What do you expect? This is the self-improvement arc. Doesn't mean I'm gonna get rid of my lack of common sense. Is this song too loud? I can't really tell. Had your hopes up. Oh, damn. Sorry to disappoint you, Jump. Okay, you think it's fine? It's just really, really loud in my headphones. I feel like I'm shouting. Mechanical energy. That's like kinetics and stuff. It determines the size of the orbit. Music might be a little bit now that okay, I'll turn it down. Is that better? Bop. A little overwhelming when you're not talking. Dude, silence is always overwhelming, isn't it? I'm just here. I'm defined as the semi-major axis A of a two-body system. It's only loud when you're not talking. Is that a good thing or a bad thing? That is what I cannot decide. Defined as the semi-major axis A of the two-body system, E mechanical energy is equal to negative G mm. Now the music is dead. Well, shit. We've got a real problem on our hands, don't we? It's either too overwhelming or not overwhelming enough. And that is an issue. Dun, 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 dun. Ba, da, 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 da. Looks like I'll just have to keep talking. It does fit my... It does. M tier streaming, always. On the daily, that's me. That's my content. I would like an astronaut to please join this stream and assist me. I am the big struggling right now. If someone wants to give me a crash course in Kepler's law that is not provided by one of the Green brothers, that would be phenomenal. I can try to learn it all I want, but my efforts remain futile if it's only half-assed learning. Ba ba. Da. We got the water. I opened my fridge today. I still have one lemonade in there, so we will have a lemonade a little later today. I'm very excited. The angular momentum L determines the shape of the orbit. Try. Yeah, try. Overall, like, I'm a decent student. I try my best. No, I actually have no more cheese sticks, and I'm very disappointed because I really, 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 really want some cheddar cheese. However, I lack the resources. I lack the cheese. Maybe. I can. I don't know if I can take my phone with me to stream. I could take you guys with me, and we can go to the store and buy grapes. I run the risk though of filming people without their consent, and I definitely don't want to break laws. The angular momentum determines the shape of the orbit. It's defined by the eccentricity? What is eccentricity? Alright, wait. What is eccentricity? Eccentricity, the quantity of being eccentric. Wow, that is so helpful. In Spanish, we call it eccentricidad. Did y'all know that? What eccentricity means? Technically, it should be fine, unless you're hiding the fact that you're streaming, or if I go into the washroom. I don't think I just want to go into the bathroom. And I'd also have to, like, cover up my face. I'd look like a bit of a dumbass with sunglasses and a mask on. It is sunny here, though, so, like, oh, no, it's, like, overcast. Eccentricity just refers to, like, how far away from a circle it is. If it's infinitely eccentric, if there's infinite eccentricity, it's a straight line. If it's 0, it's a circle. So any value in between that would be more or less circular. Oh, wait! I found an interactive little lad. Interesting. You can't see how just mesmerized I am by this little website. You can probably see me playing with it on stream, but... Oh, that's interesting. And I think we can determine eccentricity from... what amazed me the most, Kepler proposed these 3 laws back in the 1600s, and initially there was no technology at all. I guess he had so much free time, right? That is incredibly impressive, too, is all these constants and all these numbers and these laws that we follow to this day are literally, like, 500. Or he was a time traveler. He could be. We have no proof, but also, like, I don't know. But yeah, it's absolutely bonkers how this all works together. Hmm. I don't know. It's things like those that, like, remind me that science is, like, my favorite thing in the world. It's so complex, and everything in our universe just runs on these somewhat, underline the word somewhat, Kepler time travel pog? Yes, Kepler time travel pog. I never thought I'd see that sentence in a Twitch chat. But yeah, I just think it's so crazy how the universe is essentially just made of math, right? And that's what makes math just so incredible. And I've got this wonderful inspirational music playing right now, and I could, like, give you all a speech on why mathematics is just phenomenal, but I'm not going to do that because I will also sit here and complain about why improper integrals are literally the worst thing on planet Earth. The universe is just a theory. However, in science, a theory is pretty reasonably proved. Plus, with your phrasing, it makes it seem like the universe is just a big hypothetical. A film theory and cut. Yeah. Matt Pat's shaking. If Clef were here today, he would spend all his time trading bitcoins and have a meme account on Twitter. Oh my god, he would. He absolutely would. That silly, silly man. You think he'd frequent Reddit? He'd steal all his memes from Reddit and he'd upload them to Twitter. For a set of bodies in circular... Oh god, that drop scared me. I just spelled the word orbits wrong. I spelled it OBR. Obrits. Kepler would be unfortunate. No. He'd post his theories in the paranormal board. You think he believes in aliens? Okay. The square of the orbital speed decreases inversely with the distance r, so velocity squared is equal to gm over r. We're gonna write this equation in pink. It's a pink kind of equation. I will say, since studying physics, my ability to do calculus has improved, like, drastically, which is nice. I understand calculus' more important applications, and that's very, very nice. I very much like that. So, the smaller angular momentum is determined by whatever has the smallest eccentricity, I think. And that's all my university has on Kepler's law. Let me pull up the, second section on it. Oh, no. We have the energy equation. We have, third law and stuff. We've got that. Rotation and apparent weight. Because the Earth is spinning, the normal force resisting weight varies across the globe. At the equator, part of the weight provides centripetal acceleration, so N, normal force, and apparent weight is smaller. Notice that... Uh-oh. What'd you try to do? Oh, did you try to post a link? I don't think chat lets you do that. I'm terribly sorry. If it's a link you want to check out, you can send it to me on, through Twitch Whispers. Ba, ba. It's okay. Okay. No worries if you're fine with it. Ba, ba. Dun, 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 dun. The equator velocity is over radius. You can also send it on Discord. Yes, you can. Shell theorem. A uniform spherical shell of matter exerts gravitational force, which is gravity m shell m over r squared. The object outside the shell, same as the force it would exert on all the mass, concentrated at the center. All objects inside. I'm skipping the. I don't like when there are words in my music. Oh, hell yeah. The Squeedle song? Oh, wait. This has words too. Me and my homies. When I'm talking, I don't like when the lyrics talk over me. I don't mind music with lyrics. That's not to say that, but I also just do not vibe with lyrical music. When I'm streaming. Y'all, I'm sleepy. I have been up since 7:30. It is 1:17. That's not a lot of time, but it feels like a lot. Imagine a planet with uniform density. The inhabitants of this planet have drilled a hole straight through its center. Are these more words? I feel like I'm in church. Okay, you know what? We're gonna listen to, what album is... I like Clark Powell, so we're gonna listen to his stuff. Clark? How do you spell Clark? Clark Powell. It's off of volume 8. This is Flare. Flare is my favorite. Okay. The inhabitants of this planet have drilled a hole straight through its center from one side to the other. What is the acceleration due to gravity at point R from the center when R is less than the radius of the planet? Recall that the volume of a sphere with radius R is 4/3 pi R cubed, and that mass is density times volume. So force is just equal to mg. So it's mass inside is density times volume. And force is equal to the force of gravity, which we find by big G multiplied by big M over R squared. And we set that equal to mg. I think we can divide by m. That gets rid of one of the m's. And I think the r's simplify, so there'll be an r on top. Is the only acceleration experienced by this the acceleration due to gravity? Unless we could also do F equals ma and then solve for it like that. Well, in that case, if F is equal to ma and the only force being acted upon is mg, A is equal to g, right? That's how it works. Superposition. A thin uniform rod has length L and mass m. A small uniform sphere of sphere of mass m is placed distant x from one end of the rod. Along the axis of the rod, see the figure, what is the force of m? I know this on the piano. If we hit a follow goal, I'll play the piano next time. That's my, like, one thing. Earth density varies with radius. By shell theorem, we can assume that Earth is a point mass. Note, Earth is definitely not quite spherically symmetric. That's interesting. That means that there are anomalies in gravity. The follow goal should be karaoke stream. We'll just make it music stream. I can change that right now. Oh, maybe I can't. I'll have to wait till the stream is done. I would love to do a karaoke stream, except I do not know how to sing. Dun. Y'all, we rocking with this? I sure am. Oh, yo. Kind of a spicy drop there, boys. But look at how distracted I get. Simple harmonic motion. I actually really understand this, and I really, really like it, and I think springs are so cool. I do not like Kepler's law, but I can mess with simple harmonic motion any day of the year. Da, 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 ba, 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 da, ba. This is in the key of G. G is my favorite musical key because it's so good. It's got two sharps. It's F sharp and C sharp. They're really cool. G minor is even cooler because it has B flat, and I think I just spilled water all over my notes again. I think B flat's a pretty rockin' color. It's the concert key. If you're gonna play a scale in like band, you do it in the key of B flat. And C-tuned instruments don't need to do any work to play any transposition to play a B flat scale. Playing a B flat scale on the piano, however, is probably the worst thing ever because B is a stinky key. But it's also a really pretty key. Alright, simple harmonic motion. That's springs, that's waves, that's pendulums. Anything that goes back and forth, I think, observes some variant of simple harmonic motion. We're going to make simple harmonic motion teal, because teal is my favorite color, and this is my favorite unit. Simple harmonic motion. Woohoo! What's that instrument playing like up there? It's very pretty. I like it a lot. This is less Maddie learning physics, and it's more just her talking about the music. Oscillations. Let's think of some examples of oscillations, guys. We got simple pendulums. Mass is fixed to a spring. An electrical circuit, an inductor, and a capacitor. A bob up and down in the water. Physical pendulum. A swing. Tonal oscillator. Column of air expanding, and I can think of wind instruments. Flute. I can play the flute. Solid rods. All of those will observe oscillation. Grandfather clocks. Okay. I just think the word oscillation's a neat word. Oscillation. Alright, what can I tell you from these notes that I'm looking at about big boy oscillations? A system in mechanical equilibrium will arrive at a minimum mechanical energy, Ux. I believe U represents potential energy. A system in mechanical at a minimum minimum's such a weird word. Dum, bum, bum. Ooh. Yo. Bum, bum, da, da. Da, ba, da, ba, da, da. Da, ba, da, ba, da, ba, da, da. Ba, 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 ba. Planetary movements and pendulum and harmonic stuff all at the same study session. You weren't lying when you said you were speedrunning physics. Not at all, not at all. There's actually a lot more. I'll run you through the list real quick, what we're doing. So, yeah, the first session that we did was Kepler's Law, and we had a small little bit on Kepler's Law. And so then after Kepler's Law, we moved to, oh, I lost my tab. We're moving to simple harmonic motion. And then after harmonic motion, we're doing dampened and driven harmonic motion, mechanical waves, standing waves, and an introduction into fluids. So we are hitting all of the boxes tonight. I am gonna do my best to learn this. I have an exam in literally 5 days. I have covered some of this in class, so it's not like new material to me per se, but it's material I haven't completely like retained yet. So I am just kind of streaming and like talking through my thought process to an audience as a way to help me remember. Simply because it's just, I found I did like a math stream like this earlier in the month, and that was really, really helpful for me just because I was able to kind of go back and forth and do all my math homework, and I did really, really well in that exam. It was honestly the best exam I've had all year, and that was kind of a great feeling. Yeah, I did really well above the average, and so I've just found that whether or not even someone's like here to watch me do my physics, it really helps me remember more than anything else, and that's what's most important. No, and also the title isn't clickbait if it's true, let me tell you. No, because once I get all these notes done, I will probably go and do like some practice problems. We'll start with Kepler's Law, and we'll move to like motion and stuff, and yeah. Well, if it works, it works. I really enjoy these kinds of streams. Oh, that's exciting! I really enjoy providing them because it's very much like a really efficient way for me to not only study, but like provide entertainment and like make content. Double dipping. It's really, really nice. Okay, the kinetic energy equals 0 when EMEC is at minimum. Kinetic energy, okay, equals 0. Funny little arrow, EMEC is a minimum. Woohoo! The potential energy will depend on some coordinate, like position, angle, volume, density, area. At equilibrium, potential energy at x naught equals min, and then it's... Oh, is that an integral? It might be. You. Me and my homies aren't rocking with integrals. As soon as physics tells me to integrate something, I kind of check out. It's very intimidating. we just got our introduction into fluid dynamics too, and though it's interesting, I've gotta be honest. I didn't think fluid dynamics would involve integrals as much as it does, and I don't know if I'm here for it. Or not fluid dynamics, like buoyancy and stuff. You know, that's technically fluid dynamics, but maybe it's not like the fluid dynamics you all are familiar with. I haven't learned any. I never took physics in high school, so I'm at a very big disadvantage. But that's okay. You're too tired for this big talk. What do you mean? We're just getting started. It's only 1 in the afternoon here. 1:30 in the afternoon. We are here to have a good time. It's not my goal to teach you something. At the end of the day, it's for me to learn and you to comment, so. Potential energy will depend. I've only had 1 cup of coffee. I have 2, but it was an espresso shot and it shows. Well, I graduated 4 years ago, so I forgot all about fluid dynamics. I'm kind of an Excel engineer now. Haha! Dude, yeah. That's the really interesting thing with how I'm learning physics right now. Our entire lab section, even though it's online, obviously, given the current conditions, we all have to learn online, which is fine. I'm content with that. My physics lab is still like something that happened and like went on and was like a regularly scheduled meeting. We met once a week, and whatever else. It was really, really great, except I had to do my entire physics lab in Python. And I didn't learn how to code in Python. I know C++, but so that was really interesting walking into day 1 of my physics lab, and they're like, yep, we're going to teach you Python in these 2 hours, and you're going to use it for the rest of the semester. And it's fun. Python is easy, especially if you have a background in C++. There's a lot of overlap, but I guess the way we applied Python was very, very foreign to me, because I'm very much used to like writing programs that are essentially just over-glorified calculators, and a lot of like the stuff we did with Python involved, because it's like vector algebra, right? So you have to use arrays and all those fun things, and I really, really hated doing arrays in C++, and I've learned that my hatred also extends to Python. But back on the subject of it, I just think it's very, very interesting that that's how they chose to teach the lab. But it makes complete sense, because I think a lot of today's current engineering world is so incredibly dependent on software and software development, and anything a computer do, you're going to, it's going to intersect with your job. You know, like I'm doing all these calculations on paper, but chances are there'll be a computer to do them for me come the future. I might have to write the code for it to do it, but that's okay. Equals min as approaches. So we've got du. Oh, it's negative. I forget that potential energy is always negative. Ba, 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 da, 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 da. I'm trying to think of like other music we could listen to. Dun, dun, dun. Because right now I've just got. Should I put on the speedrun music? I don't think I'll subject you to that. We'll listen to Impossible to Play Symphony. I think that's, if I can spell impossible correctly. Impossible to play. Symphony impossible to play. Sorry. My favorite one off this album is Serenade. It's a very, very pretty song. Not in the future. I'm actually using software to calculate everything for me. I haven't used a pen and paper in a long time. That's really interesting. That's really interesting. I find a lot of joy in being able to do math by hand because there's just something like there's beauty in the long calculation process, I think, because that's how you like get the fundamental understanding of like, yeah, this is how these numbers work together, and this is how they intersect, and this is their relationship with one another. But at the same time, it's incredibly easy to just plug and go. I wish everything was just plug and go with how you do numbers, and I guess that's like the one thing I have to look forward to when I finally do like get a job and stuff, is even though I'm sat here and I'm learning about oscillations and I'm going to do the calculations by hand, and it's something I do kind of struggle with, that process will be easier once I leave college because it won't be dependent on my faulty math. Ba-da-da-da-da. I don't know. I think, especially in the American school system, there's just such an emphasis on like, oh, you're not going to have a calculator when it comes time for you to actually do stuff, and that is very much not true. It kind of sucks. U of x naught must have a positive curvature. I have a positive curvature. Da, 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 da. That flute is so funky. I love him. He's going off. Ooh, okay. Aladdin music, not quite. It does kind of have that vibe, though. Chinese class just ended. Woohoo! Congratulations for being... You're free too, Tempest! You and Jemp both are. Oh, that's so triumphant. Dude, that flute is wonderful. I wish I had perfect pitch, guys. Like, that's the one thing I wish I, like, learned as a kid, was perfect pitch. You're gonna 3D model something! You guys are on lunch break right now, wow. That's cool. What are you gonna model? Or do you not know yet? I spelled the word curvature wrong, guys. I forgot the V. It's curvature. God, there's a reason I'm a STEM major. Curvature. There we go. I spelled it right. F equals negative du over dx. That drum scared me. It's quite dramatic. But you know what? He's grooving. I'm grooving. We're all grooving. I love these numbers. Bum bum bum. You can't see me, but like, you know that cat? Like that cat that like bops his head? That's me right now. I wish I could play the drums too. Right? Drums are so cool. I big props to anyone who can play the drums. I'm a little all over the place today, chat, and I'm very, very sorry. But, we're learning. We are learning. I promise you. It's just, it's not necessarily a linear graph we're looking at in terms of learning. It's like, it's like a sine wave. I'm learning in a sine wave. You know, there's highs and lows, but the amplitude is constant. I like this funky instrument. I don't know what it is, but it's like, what does it mean when the equal sign has 3 lines? Second derivative. Me and my homies don't like second derivatives. Bum, bum, bum. Oh, spring constant. That's K. Constant. It represents the force per distance of deviation from equilibrium. The SI units are newtons over meters. That's interesting. Force per distance from deviation from equilibrium. I spelled constant wrong. You know what? If I'm feeling really, really bold, I can send a link to my physics teacher. Be like, hey, professor, look what I'm doing right now. And then he could judge me. For the whole world to see. Yes, this is what one of my students is doing. I'm so glad she is doing this. Did you guys know, this is so unrelated, but like I just need to talk while I'm writing. So when I first started streaming, I would play like Minecraft and stuff. It's just fun. Everyone likes Minecraft. Minecraft's a fun game. I would play like Chopin and like classical piano because I assumed, you know, classical piano is kind of old. So certainly it's in the public domain. People have copywritten old classical music, and it's very, very stinky. Because I know Sir Chopin doesn't have to worry about DMCA, nor does he have, like, freaking agents who are just tuning into every Twitch stream and being like, yes, she's trying to play silly block game with Frederick's songs. Sorry, we gotta mute your VOD. You know, I don't... would Chopin appreciate copyright law, or would he be opposed to it? Something I think about a lot. Oh my god, you use a Taylor series for oscillations. I know what a Taylor series is now, guys. I learned it like 2 weeks ago. I'm not gonna write down the Taylor series though, simply because it hurts to look at. As soon as math got exclamation points, I started getting worried. Does math need exclamation points? I don't know. Oh, this is my favorite off this album. Anything with violins, and I'm like, ooh, yes, I love you. Restoring force. Small deviations from equilibrium lead to a restoring force. A restoring force leads to oscillation. Repeated motion about a point of equilibrium. And there's a silly little diagram to go along with this. See, listen to that, like, falling arpeggio. Isn't it so nice? Oh, I love it. I just realized you guys really can't see. I'm writing at the bottom of my page, and as I move to the bottom of the page, you can't really see. That's not very Cash Money. What does equilibrium represent? Is that just like when it's like resting? No, equilibrium's when it's fully stretched out. So that because it's here, wait. Imagine you need to test restoring force, so you take apart your pen in the middle of the physics exam to observe spring. So the spring is in equilibrium when I'm not pressing on it. When I go like this, it's no longer in equilibrium. So it's only in equilibrium when it's like this. So displacement to the left, restoring force to the right. So it's the spring's natural need to resist the pressure of my finger. Here, wait, you guys can't really see it. He's tiny, look at him. So restoring force, when it's coming, I guess, from both sides, I need to like hold this constant. Here. Not me setting up my own science experiment to understand equilibrium. I dismantled this poor pen. You can't really see when I do that. There, thumbs up, thumbs up, thumbs up. That's quite a wrist movement. We have Scotch tape. Uh-oh. Where's the... Y'all, I hate when tape does this. Okay. Okay. This is the most janky experiment ever, but this is what I get for not being able to go to a physical lab. Okay, you have broken pens and pieces of tape and post-it notes. And you know what? I'm thriving off of it. Dun 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 dun. Scrumptious piano. Bum bum bum. Okay. I have successfully suspended this string to this spring to a sticky note with a piece of tape. So now, restoring force. Here, can you see chat? Restoring force, if I push this in. Where'd it go? Where did it go? Can I get an F in the chat for my pen? We might not be able to fix him if I cannot find this spring. Uh-oh. Uh-oh. Oh, wait. No. Shoot, guys. Uh-oh. F. Thank you, Tempest. Yeah. Big L. I lost that spring. I just wanted to demonstrate restorative force as a deviation from equilibrium. However, can't really do that when you don't have a spring. This music is very triumphant. I'm gonna turn it down just a titch, guys. Okay, new plan. We're gonna go back to whatever we were doing before. And, I'm just gonna remove the evidence of my crime. This pen, what was this wonderful, wonderful Sharpie pen. I will look for the spring off camera. I will, because it will probably take me like 30 minutes to find it. My carpet is gray, and it is somewhere in that sea of gray, and I just don't have the heart to look for it and spend 30 minutes trying to entertain you while I aimlessly look for a spring off camera. But that little lad, he flew. Is that an example of restorative force? As Newton's second law, or Newton's third law, right? For every action, there's an equal and opposite reaction. That reaction would be the spring flying off the sticky note as a result of over-applied pressure from my finger. Look at that, guys. Physics in motion. Caught live on camera. Caught in 4K. This is not 4K. It's not even 720. I don't know what it is, but it's not good. Because you can't read any of this. Ooh. I told you, chat, if it's got arpeggios, there's a chance that I really, really like it. Alright, I've got to look for another black pen. Whoops. Alright, let's do that. If I were a black pen, where would I be hiding? I probably have like a bajillion of them here in this pencil bag. It's the first one. Sharpie makes pens. Sharpie makes gel pens, and they're very nice. But I'm like one of those people that like definitely has a favorite pen brand. I really like the Pilot pen series. Those are definitely very good. Lead. Okay, it's a restoring force. I've been getting the word wrong this entire time. Repeated motion about a point of equilibrium. Oh, yo, this is a classic. It might be DMCA. I don't think it will be. If it is, that's fine. We'll groove. We'll groove. Bum. Or I could just play it on the piano for y'all. Page. Oh, it's all ripped. Oh, it's from water. Wonder how that happened. Alright. Big RIP to my notebook. Now it looks like some beast has eaten it. Bookworm! Bookworm! Yes. You think there's a species of bug that eats books? Well, no, I take that back. There's most definitely some kind of bug that eats paper. But, like, you think libraries have, like, infestations of that hypothetical bug? Usually I'd put it up here, but I've got to put it all the way over there because, whoops, ripped my book. There are bugs that eat wood, and paper is made of wood. There's a chance, yeah. Like not termites. I don't think termites would eat books. Okay. This prompts another Google search. Can termites eat through paper? Termites can eat through paper because, like wood, it contains cellulose that termites are after. Once the termite eats through the paper, it can chew through and burrow through the plaster material. Termites also have the ability to eat through cardboard, cloth, and other plant-based materials. There's your answer. Does paper... Does it? Is that how it's made? Because, like, you can make paper, essentially, with just, like, this, like, pulp and, like, water, and you put it through a screen and, like, let it dry, and that's how it is. Okay, do termites eat normal paper? MyTermitesTreatments.com. Yep. It looks like they do. You read about it once. That's why paper has the red lines, like notebook paper? Or like just everyday paper that's like threaded with like some red line that I'm forgetting about. Okay. That's interesting. I would have never thought of it like that. Bum 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 bum. Bum 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 bum. F equals delta U dx is equal to negative kx, and that's how we get, I believe that's Hooke's law, or we're getting close to Hooke's law. The reason I'm taking all these fun, detailed notes too, guys, is because I'm allowed to use notes on my exam. So, the more thorough they are, potentially the more helpful they are. I don't want to spend, like, a bunch of time pilfering through notes. However, it's important to... I have to, like... Oh, excuse me. I have to write it down in order to, remember it. I forgot I was wearing makeup, and, like, when you yawn, you cry. I don't remember it that well, but it was said the people who wrote in paper had their paper eaten or destroyed by bugs, so they added red borders of some chemicals to keep bugs away, and it worked flawlessly. Bugs ate around the red lines. Ate around the red lines, but kept away from them. That's interesting. Huh. I would have never thought about it like that. I don't know. Maybe I'll get some termites and like an old textbook and see if they'll eat the textbook. Perform an experiment. Dun, 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 dun. Dun, dun, dun. Okay, apply Newton's law. Dun, dun. Dude, that synth is so grooving. Negative kx equals ma equals m d squared x over dt squared. General solutions to the second order linear differential equation. Ugh. Those sound like gross words, chat. Differential equation. Scratch, scratch, scratch. Bum bum. Okay, so then we've got acceleration is equal to that, which is equal to omega x, and I see cosine. Okay, wait, I recognize amplitude cosine, and then in parentheses omega t plus phi, where phi is the like phase shift, omega is your period, t is time, a is amplitude. Phase constant. It's called a phase constant, not a phase shift. Technically it's a phase shift, but the variable itself is the phase constant. I do recognize. Oh my gosh. I need water. I do recognize that. Let's write some equations. I think this fun blue color will do. Okay, so acceleration is equal to d squared x over dt squared, which is equal to negative omega squared x, where x is equal to boop, 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 curly bracket, a cosine omega t plus phi, b cosine wt plus c sine wt. It's not a w, it's an omega, but it looks like a w, so we're calling it w. A e to the I? What does I represent? It could be inertia, it could be something else. Wt plus phi. And we know that omega is the square root of k over m, where k is a constant and m is the mass. Omega curly w. Why is omega a w? I have asked this question so many times, and it really, really bugs me, because omega like starts with an O, and if our English alphabet is somewhat derived from the Greek alphabet, then why is omega not more like an O? I guess like the uppercase omega kind of looks like an O, because it looks like that, right? But we're not rocking with uppercase omega here. Dun dun dun. Dun dun. I drew an omega on my paper. Okay, let me draw out these silly little variables. We've got A, we've got omega, we have phi, we have curly f, and we have capital T. For 10 points, chat, what is A? Maximum displacement amplitude. W is angular frequency. Phi is a phase constant. This is frequency. And capital T is the period. And we know that frequency has a few ways it can be written. We know it can be equal to F is omega over 2 pi, and it's measured in hertz. Whereas the period is just 1 over the frequency, or 2 pi over omega. And I think the period is like in an arbitrary unit, like it's obviously in radians, right? But I don't think radians observe traditional units. Oh, pardon me. Oh my gosh. This is what I get. I got up at 7:30, chat. And I am a little sleepy, and I think it shows. So, okay. The way this works then is each consecutive derivative gives you something different. So I'm just gonna reserve this whole page for these equations, simply because I feel like these will be the most important. So position is just a cosine omega t plus phi. Velocity is the derivative of that. Now, I don't want to calculate the derivative by hand, and that's why I'm just going to write this down. It's omega amplitude sine of omega times t plus the phase constant. And then the acceleration is the second derivative of the position function, or just the derivative of the velocity. If you know one, you can find the other. And that is negative omega squared amplitude times the cosine of omega t plus the phase constant. And they also have it set equal to just negative omega squared x, which I don't know why, but apparently that works. And that is all I have on simple harmonic motion, chat. Are you ready to learn about dampened and driven harmonic motion? It's one thing after another, guys. One thing after another. I'll end the stream when I'm done with my notes. I think that sounds fair. And then I'll be back maybe later tonight. Dude, is it only playing Suburban Jungle? I'm getting a little sick of it. It's been like an uncomfortably long period of time. One whole slide. Oh, I got distracted. I'm sorry. Whoopsie. Yeah, this is the extended version. This has been playing for 16 minutes. I'm so sorry, chat. We're gonna listen to Blind Justice Extended now. Hope you put up with the same song well for 15 minutes. Oh, but that's groovy, isn't it? I'm losing my energy, guys. Okay, we're gonna persevere. Dampened and driven oscillation. We already know about simple harmonic oscillations. We just covered that. We've got all the important stuff. That honking. Initial conditions and phase constant. Behavior of simple harmonic motion is the same as a linear projection of circular motion. 2 initial conditions are needed to uniquely specify the solution to a second order differential equation. And x equals this first equation. Velocity is equal to this, and in terms of the initial conditions, x t equals 0, t naught and v equals t0. It can now show phi is equal to negative inverse tangent of a velocity over let me write that down. What's tan negative 1? Arctan, that's what it's called. I'm gonna make this orange because I can't really see the green. I'm a bit blind, chat. V naught over omega, x naught, and amplitude. That's interesting how you can arrive at that. I guess it makes sense because you're just solving the equation for it. But it's interesting how it just reduces so simply like that. Over omega squared. Okay. Pulling a swing to the maximum and releasing at it's not psi, it's pi, phi, fee fi fo fum. Pulling a swing to a maximum and releasing at phi equals 0, giving a push at the bottom of a swing equals negative pi over 2. Oh, okay. I'm just looking at the graph they've given. And then the omega of a simple pendulum. That's it's such an interesting word. Pendulum. It makes a J noise. And that's just root G over L. Where K is equal to MGL. Okay. Simple pendulum is a light string or rod with a mass at the end. Potential energy. You can get the same result using the potential energy approach. The goal is to express ux as approximately 1/2 kx squared. U equals mgy, change in height, mg L minus L cosine theta. Use the Taylor series expansion for cosine theta. I don't think I will. Physical pendulum mass spread out. Physical pendulum is an extended body performing small oscillations around a pivot. Gravity is the resulting torque, restoring torque. Free body diagram first. Some of the torques is mg d sine theta equals inertia alpha. For small angles, sine theta is approximately theta. Mg sine theta is equal to I alpha. I is equal to the second derivative of that theta equation. Mathematically, it is identical to k negative kx, with x being theta and k being mgd and m being inertia. So the angular frequency in this mass spread out version is omega equals mgd, where d is distance, over I. Big boy inertia, where d is the distance from the pivot and the center of to the center of mass, and I is the moment of inertia about the pivot. But I equals ICM plus, okay, let me write that, because I will forget that. I is equal to ICM, inertia center mass, plus md squared. So then energy in simple harmonic motion. Oh, this looks like it does not seem fun. I'm just here, a simple woman, writing her simple little silly equations. Total mechanical energy is 1/2 k amplitude squared, which is equal to 1/2 velocity squared, independent of time. Why is it independent of time? It must be derived from elastic potential energy. W squared is equal to k. W squared is equal to k. K plus u. Maybe they don't cancel, do they? Yeah, they do, because if you have sine squared plus cosine squared, you just get 1. I'm a clown out here forgetting my trig identities. Okay, so then the mechanical energy of something in simple harmonic motion is 1/2 the spring constant times amplitude squared, which is equal to 1/2 mass times velocity squared. This bad boy is time independent. Pendant. Okay. I just want to learn about dampened and driven oscillations now. Oh, wait. What happens when you double amplitude? Mass on a string oscillates with amplitude 8. If you double the amplitude, the energy of the system becomes 4 times as big. Why is that? Oh, because 2 squared is 4. All right. Okay. Dampened oscillations. That is what we're learning about now. What color radiates dampened oscillation energy? I want to say yellow, but yellow won't show up. But it's certainly a yellow subject. We'll go with pink. This obnoxious bright pink. Look at that. Oh, y'all want some light? Wait. There. There's still a smiley face on the lava lamp. Oh, wait, let me... Okay, there we go. Okay, dampened. Dampened oscillations. Okay, real oscillations eventually stop because mechanical energy is lost due to dampening friction. The oscillation amplitude gradually dies away as energy gets lost. The rate of fading depends on the nature and amount of friction, the strength of the restoring force, and the inertia of the system. All things at stable equilibrium are actually dampened oscillators. How can you tell? Disturb them and see what happens. And then there's a YouTube video, but I'm not going to play the YouTube video. And there's a little bit of math associated with this. There's math everywhere. I don't know if I like it. Is energy lost in the form of heat? Or does spring get hot? Can it cool? Chat, I'm gonna change stream categories. Okay, there we go. I need to get off Discord. I get so distracted, guys. It's not even funny. I can't get my work done. I need to get my work done. I need to get my work done. Mi trabajo. Alright, rate is dependent on nature, amount of friction, strength of restoring force, and the inertia of the system. Okay, now for some fun facts. It didn't really work now, did it? There we go. You did not just see me struggle, okay? What's B? It's part of the force of drag. AE BT over 2M, and it's negative. Cosine omega prime T plus phi. Hey, let's see if Foggy's still alive, guys. Let's bug Foggy. Actually, they might be. They're not. That's stinky. Having a big think here, guys. Bum 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 bum. Ba dun dun dun. Ba dun dun. I don't know if I can handle this song on repeat because it's the extended version. Carnival. That's oh no, yeah, it is Carnival. Dun, 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 dun. Okay. I need to get back to the task at hand. This bad boy is exponentially decaying amplitude. And W prime. Any primers? Kidding. Oh, we should make that a thing. Anytime I say prime, someone... Maybe. B squared over 4M squared. Cool. This represents a decreased frequency depending on the dampening. So, dampening impacts not only amplitude, but also frequency. Okay, there are 3 cases. Okay, I do remember this from class. Not well, but I remember it. We have underdamped. If something's underdamped, what can we say about it? It's going to observe this equation. Oh, no, it's just the differing values for B. I'm sorry, I am a fool. I don't want to spread misinformation. Do not take what I say here as fact, simply because I don't know if it's fact or not. Okay, if K over M is greater than B squared over 4M squared, meaning that B has to be less than the root of 4mk. So then we have if something is overdamped. where B is greater than the square root of 4mk. No oscillation, only decay. What an edgy sentence. Dun, 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 dun. The greater the B, the longer towards equilibrium. And then critically damped. This just looks like it's not a plateau. What do you, a ravine? No. What's it called? What's it called when it steeply drops? Critically damped. No oscillation happens here too. Exponential slide back. And B is equal to 4km root 4km. Sorry. So we have driven oscillations, and then we're done with this section. How many more slides do we have to go? Or like, not slides, but like subjects. Mechanical waves, standing waves, fluids. 3 more. Tell you what, chat. Since I've got 3 sections of notes, after I finish, dampened and driven oscillations, I'm gonna take a break just to like check my notifications and step away for just a minute, watch a little bit of TV, take some time to relax. Ollie will be back, and we will do mechanical waves, standing waves, and intro to fluid. And maybe some practice problems. Maybe if we're feeling risky. Okay. Driven oscillation. Driven oscillation. If friction consistently takes energy out of the system, how can oscillations exist? Something's got to supply energy. In other words, something must drive oscillations. What can it be? So like when you pump, like when you're swinging, that's you providing your own energy to the system, right? So that's a driven oscillation, I believe. Okay. Friction is always acting in an oscillation, right? Unless it's like on ice or something. Out of the system, how can oscillations exist? Supply energy? Question mark? Driving force. I.e. a motor other oscillators, sorry. Oscillators, hand. Okay. If the driving force does positive work, i.e. it's along the displacement most of the time, then it can increase the energy of the system. Okay. So, if the driving force... I can't read all of a sudden. Does positive work, along displacement most of time, parenthesis, it can increase the energy of the oscillating system. We call these bad boys forced oscillations or driven oscillations. And there's a model for the forces, and I've got another equation. If I had a penny for every time I said the word equation today, I would be able to receive a Twitch payout. Equals negative kx minus bv plus f naught cosine omega dt. That sounds like fun. The last term is the periodic driving force with angular frequency. So this bad boy. Oh, that's not how a pen works. Periodic driving force with angular frequency WD. Omega D. Sorry. Omega D? Omega D? A child on a swing is a pendulum oscillator. If you push periodically at the right time, you do positive energy and supply. You do positive work and supply energy. You drive the oscillation. These two frequencies do not have to be the same. In general, they are completely unrelated. However, if they are the same, where WD is equal to W, a phenomenon called resonance occurs. I'll just write when in blue. WD is equal to W, resonance occurs. Pog. Alright, this is the last little bit I have on dampened and driven oscillations. And then I'm gonna call it here. I will be back later to do work on waves. But first and foremost, we get the oscillation taken care of. I'm gonna get lunch, check my notifications, because I can't check my notifications when I'm on stream like this, because my phone is my camera. I know, really big smart decision on my part. What is the frequency of small oscillations? Oh yeah, springs in parallel series. Parallel forces add directly. Series displacement also adds. Let me write that. Parallel series. We've got F total, F tot is equal to K1 delta X minus K2 delta X. So in total we've got negative K1 plus K2 delta x. Oh god. Same tension F. I know this one, so it's delta x equals delta x1 plus delta x2, which is equal to force over k1 plus force over k2, 1 over k f equals 1 over k1 plus 1 over k2. Okay. We already know the stuff for the different values of B. We know driven harmonic motion is given by the equation we just wrote. We know what a forced oscillation is, and we know what a resonance curves. Oh, I don't like the way that looks, guys. If you could see what I'm seeing, you would want to vomit. Steady state solution x equals, yeah, with F drive, A equals, ugh. F naught over, this is a doozy, chat, parentheses, K minus MW squared D, all of that squared, plus B squared WD squared. Ugh. And that's just for the different amplitudes given the differing values of B. And that is everything I've got on dampened and driven oscillations. With that being said, chat, it's been real fun, but breaks are necessary whenever you're studying, especially when you've been studying for nearly over 2.5 hours. It's been really productive. I felt like I've gotten a lot of notes done. And so I'm gonna end the stream here for now. I will be back later to tell you all about waves, and we can talk about waves together. But for now, I'm gonna go grab lunch. I'm gonna talk with some friends. I'm gonna watch some TV. I'm gonna relax. And then straight back to the drawing board right after this. So, yeah, thank you all for stopping by. It has been a lot of fun. And I will catch you in a few hours. Thanks!